What's up, buddy? Oh, good. Hey, guys, Mr. Jenkins here. This will be your first lesson of Chapter 4. We'll be in Chapter 4 for a long time. We skip around a little bit. Really, we end up covering it as 2 separate units. So this will take up the better part of the quarter. So all important stuff. It's all about quadratics, which you may or may not have covered. Well, you guys, depending on when you took Algebra 1, you may or may not have covered this. I know that a lot of us didn't get to it at the end of last year, but it is covered in Algebra 1, so some of you guys will have the advantage over others. That being said, if you have questions, just, you guys speak up and let me know. So first of all, a quadratic function is an equation in the form a times x squared plus b times x plus c. Basically, the degree of the rule is 2. It's a second degree rule. It contains your input variable squared. All right, and then if you see that, if it's in that form, then you know that the graph of the quadratic equation is a parabola. And if you don't know what that is, it's over here. This is U-shaped looking graph. Kind of an important thing. Notice it says axis of symmetry here. It's the exact same on both sides. It's reflected across the axis of symmetry. All right, so we want to, for our first exercise here, we want to circle the parabolas and cross out the others. Pretty easy exercise. So which ones have an x squared? That would be this one and this one, and not these two. All right, so if we punch these function rules into our graphing calculator, what we would see is the 2 bookends here would be linear. I know that because they're first degree, and then the 2 in the middle there would be parabolas. They would be some type of U-shaped graph. I can also tell other things about them, which you'll be able to tell by the end of the chapter. Like I can tell that one would be upside down. I can tell that one would be start above the x-axis. But the important thing is here that you know that they're just parabolas for right now. All right, there's a key concept here about what is the parent function of a parabola, and it's the simplest form. So y equals x squared. Right, so it is important that you get familiar with this set of points. So this graph has 0, 0. It has 1, 1. It has 2, 4. Right, which makes sense because 0 squared is 0, 1 squared is 1, 2 squared is 4, and then it's the exact same on the other side. -1 goes to 1, 2 goes to 4. That's kind of the general outline of a parabola. Okay, so let's go ahead, and this one wants us to use our graphing calculator to graph and state the, we want to graph these and then state the transformations to the parent function. All right, so really, based on what we've done this year, you might be able to see these transformations without your graphing calculator. But I'm going to do it like it says, and I'm going to leave example 4 for you. Okay, so I'm going to go ahead and go to y equals in my calculator, and it's already punched in. Okay, so 2 parentheses, x plus 3, close parentheses, squared, and then -1. All right, and then I'm going to go to my graph, and there we go. So from the parent function, one thing you always look is where's your vertex. Looks like my vertex is at -3, -1. So we'll start with that, the easy stuff. So the -3 part, it moved us left 3. Think about what did that, right? The +3 in parentheses. We've heard this before. The -1 outside parentheses is what moved us down 1, okay? Down 1 unit. And then what's this 2 do? Okay, so that's going to be your your vertical stretch. So if you look here, you know, if you think about your parent function, you would go from your vertex up 1 over 1. Well, this one you go up 2 over 1. Okay, and then you could also go up, instead of 4 over 2, we go up 8 over 2. Okay, so this is a vertical stretch where A equals 2. Okay, but again, like I said, maybe a nice exercise for you guys would be see if you can name all the transformations here without your graphing calculator, and then check it in your graphing calculator. You can find the answers there on the filled out notes. All right. Next, we want to try to match these equations with their 4 graphs. And I'm going to try to do that without using my graphing calculator. Okay. So on A, we have +3 in parentheses. That's the only thing different from my parent function, which again is just y equals x squared. In parentheses means we're going to move left or right. Remember, the left or right is always counterintuitive. So the initial thought is probably right 3, but that's actually left 3. So this would put my vertex at -3, 0, which is right there. So that one is going to be A. Okay. Looking at, let's maybe look at C, and then I'll leave the other 2 for you guys. All right, so looking at this one, this -2 in parentheses would move me right 2. And the +3 outside parentheses would move me up 3. So I'm looking for one with a vertex of 2, 3. Looks like that's going to be our winner. So this is C. Okay, so between these 2, which one is B and which one is D, right? Maybe try that on your own and then check it in the notes. All right, so now we're getting to vertex form, which is basically what we have seen our equations so far listed in. All right, so for vertex form, our vertex is at H, K, where there's H, there's K. Remember, inside parentheses is always left or right, outside is up or down, okay? Axis of symmetry would equal, would be X equals H. We'll get more on that later. And then A determines the direction of the opening. And specifically the sign of A. Positive opens up, negative opens down. All right, so the domain, remember, of any function is the set of all x values for the equation, or the set of all x values for the equation for an up-down parabola, usually so remember, domain is side to side. Sorry, I was a little confused reading those words. But the domain is side to side. So even though if you think about a parabola, I'm using this one here as an example, it looks like it's going to go straight up and down eventually, and it does get closer and closer to straight up and down, but it never goes straight up and down. That means that our domain is usually from -infinity to +infinity. Okay, which looks like that. Or we could just say all real numbers. The symbol for real numbers looks like that. And then the range, which is the set of y values, we always think about the y coordinate of the vertex, right? So, you know, we're thinking about k for that one. Okay, so for this one, again, same example. We can see that it would be all real numbers that are above -2. Okay, so for our range, we would say y is greater than or equal to k, or y is less than or equal to k. It just depends on whether it opens up or it opens down. And then the minimum or maximum value is the y-coordinate of the vertex, also known as k. Okay, so based on all that, and some of this is kind of abstract, it'll make more sense probably as we go. That's the hope. My formatting here is a little bit weird, so I'm just going to rewrite the vertex and AOS over here. AOS means axis of symmetry. All right, so it wants us to use our graphing calculator, but really we might be able to do it without. We'll go ahead and use our graphing calculator just because those are the directions. Or you could use Desmos, right? So y equals 2 parentheses, 2 times the quantity, x plus 2, close my parentheses, squared. So I'm going to hit the x squared key, or you can do caret key 2 there. And then minus 5. All right, now I'm going to look at my graph, okay? So it's kind of hard to tell what's what there, right? So it looks like my vertex is -2, negative something, which is going to make sense, right? So -2, -5 is the vertex, right? If you're not sure, you can always look at the table, okay? Which we'll get to that later. Vertex, -2, -5. That's always going to be your starting point, the most important point. If you get that wrong, you're screwed up from the get-go. -2, 1, 2, 3, 4, 5. All right, then we don't just want to make a generic shape. We want to be accurate from there, okay? Before we do anything else, though, we're going to name the axis of symmetry. All right, so remember, that's this line right here. It's that imaginary line that splits your parabola in half. Okay, so this is the line x equals -2. Okay, if you ever forget that, where can we find that number? Right there, it's the x coordinate of our vertex. X equals -2. All right, so we have that. Let's go ahead and try to put more on our graph now. Okay, so instead of just trying to copy this, I'm gonna find some actual points. So I'm gonna go to my table. So I'm gonna hit second graph, and I'm gonna find actual points. Right, so I'm gonna go to where x equals -2, and I'm gonna look around that. All right, so there's my middle, -2, -5. Right, and I'm gonna plot these other points. So -4, 3. Would be right there. We have -3, -3. And then we know on the other side they're going to be exactly the same, right? So up 2, left 1 means I can also go up 2, right 1. And then here I went up 8, left 2, so I can go up 8, right 2. Right, now I have a really accurate graph. I'll go ahead and finish it by making it a continuous function. Okay, so this wants to know, is the vertex a minimum or a maximum value? Okay, if it opens up, it's a minimum value. This is my smallest y value, whatever the y coordinate is in my vertex. So it's a minimum. What is the value? So what's the y value of my vertex? -5. You could say y equals -5. You could just say -5. Either way. My domain, that's pretty simple on these. It's always going to be all real numbers. On the notes, you can see some different forms. I put that also in interval notation, and I also put it as a compound inequality. So if you want to review any of those, that might be a good idea. And then the range is my y values can be anything bigger than my turning point, right, which is -5. So any y value greater than or equal to -5. If it turns up like this, your inequality symbol is always going to be greater than or equal to. And again, I gave you some different ways that you could express that on your filled out notes. Okay, so lots goes into these. You're going to use your technology, and then you're going to use your knowledge of transformations in order to kind of come up with all this information. This is a really important lesson. I'm going to leave this one for you guys. You can check it on the filled out notes. So this last one says to kind of do that same thing without a graphing calculator. All right, so we will go ahead and do that. I would say example 7 is going to be a little bit tougher without a graphing calculator just because you have an a value. Here we have really a is 1, so that's always going to be a little bit easier. So if a equals 1, it's easier. So example 7 is almost one where I would steer you toward the graphing calculator, but you're more than welcome. You're more than welcome to try. All right. So looking at this one, then, what's my vertex? Remember, vertex is always at h, k. So h equals 5, and k equals -2. All right, h equals 5, k equals -2. So my vertex then is at 5, -2. I'm going to go ahead and graph that. 1, 2, 3, 4, 5, -2. Axis of symmetry then is going to be this imaginary line right here. Which is x equals 5. Okay, and then from there, it says use a T-chart. I'm gonna just actually kind of punch this in. I will show you that I could find them without. If a equals 1, then I know I can just follow that same pattern of the parent function. It would be up 1, right 1, or up 1, left 1, and then up 4, right 2, or up 4, left 2. That might be a little bit advanced, without a calculator. But again, I would say you should be able to find the vertex and the axis of symmetry without a calculator. But maybe for these other points, there's nothing wrong with using a calculator, even though it says do without. So just to verify those points real quick, we have x minus 5, close parentheses, squared, and then -2. I'm just going to go straight to the table. Second graph. And my vertex is at 5, so I'm going to go there. That's in the middle. So we had 5, -2. We had that point. It says 4 goes to -1, which we had that. 6 goes to -1. We had that. So you can always use your graphing calculator to come up with those other points. All right, and example 7 is done for you. That's a little bit tougher problem. And again, here's what I would challenge you to do. Find the vertex with no graphing calculator, and then use your graphing calculator from there. All right, so our last kind of example here would be coming up with the equation given the graph. This is a little bit tough, right? So step 1 is we find the vertex. The vertex of this one is at, looks like -3, -1. Okay, so h equals, we would want to say -3, but remember it's opposite here because the minus sign is built in. So actually here h is +3. sorry. Yeah, h is positive 3 because it's the opposite of what it looks, and k is negative 1. All right, so what is a point on the graph? So what's another point that we can find? That looks like a point to me. Just make sure on the other side. Yeah, so we're going to use -2, +1. So x equals -2, y equals +1. So based on that, we should be able to solve for a, right? So we're going to sub in what all we have here, okay? Sorry, I said that wrong. So I guess if our vertex is -3, -1, we would say h is -3. I misspoke earlier. So that way when we plug it in, it shows as x plus 3. Anyways, let's go ahead and make our substitutions. So instead of y, we're going to sub 1. We don't know a. That's what we're trying to solve for. Instead of x, we're going to sub -2. And then it's going to say minus -3. Wait for my pen to pop up here. All right, so minus -3 is plus 3. And then plus k, so plus -1. So that's what we have. All right. So let's kind of simplify what we have. So this says 1 equals -2 plus 3 is 1. So 1a. So I'm just going to write a minus 1. Okay, and then we want to just add 1 to both sides to get 2 is equal to a. All right, so now that we know that, we pretty much have our whole equation. All right, so then it says plug a, h, and k back into vertex form. So sorry about that. So it'd be, I'm just writing out vertex form. So now when we sub our values back in, we would have y equals a, which is 2, times the quantity x minus -3, so x plus 3. Remember, h was -3, and then plus k plus -1, so minus 1. And I always do this. I forgot the squared part. If you forget the squared part, that's going to make it all wrong, okay? So I should have had that squared there because that's part of vertex form, and that's an easy step to forget. Without that, it's just an unsimplified linear equation. All right, so let me maybe do one more a little bit quicker, and then that'll wrap it up. This is done on the notes, so maybe pause the video and try it if you think you get it, but I'd like to work this one out because this one's a little bit tough. All right, so my vertex is at 2, 7. So just right off the bat, I at least know this. Y equals something times x minus 2 plus 7. So that's the part that's pretty easy, right? You got most of it right there. All we need to do is really find a. Okay, they point out that another point that we could use is 5, 5. All right, so then this last part, this is the hardest part, is just finding that a value. All right, so we have my y value, which is y, equals what we're solving for, which is a, times the quantity x, which 5 is our x value, minus h, so minus 2, plus k, so plus 7. So there's a lot to that, but you can pause and rewind and do what you need to do on the video. Okay, and again, I forgot the squared, so don't forget that part. All right, so, and actually I forgot it in the first problem too, but it didn't affect us because 1 squared is just 1, right? So I screwed that up too. So I'm glad I did this extra example. So when we start to simplify, we get 5 equals, 5 minus 2 is 3. So you have 3 squared. 3 squared times a plus 7. All right, so let's go ahead and get rid of our plus 7 first. So when I subtract 7 from both sides, I get negative 2 equals 9a, because 3 squared is 9. Now I'm going to divide both sides by 9. And then I get negative 2/9 is equal to a. So without this algebra, there's no way you're going to come up with negative 2/9. So, you know, that's why they throw a tough problem at you. All right, so final answer, y equals negative 2/9 times the quantity x minus 2 squared. You see, I forgot it again. Hopefully, if nothing else, you see that part's easy to forget, and then plus 7. And then after all that, it's nice to have a rule that you can sub in to your calculator right here and see if it matches what you see on your screen. All right, but that'll conclude this video. We may be on this for a couple days. I forgot how much was in this section. So hopefully this helps. Thanks for your time. You all have a nice day.